Neil deGrasse Tyson has confirmed the most confusing and fearful discovery made by Voyager in the past decade. A discovery that scientists were in no way prepared for. Ever since the Voyager craft sent back this disturbing data from space, the scientific community has been unable to sleep, and everyone is walking under a tense atmosphere. Researchers, scientists, and engineers have been scrambled from their stations to combat these mysterious objects that Voyager just spotted. We don't know where these strange objects are coming from or where they are headed, but what we do know is that we have seen nothing like them before. What are these mysterious objects that were recently discovered by Voyager 1? Join us today as we dissect these answers in Neil deGrasse Tyson's Voyager 1. Voyager 1 has detected 500 unknown objects passing by in space. For almost 5 decades now, Voyager 1 has been sailing through the highways of space, exploring the deep realms that ground-based telescopes have been excluded from seeing and uncovering discoveries that leave our mouths wide open in shock. A product of genius minds at the Johns Hopkins Jet Propulsion Laboratory, Voyager 1 has been the golden messenger to the uncharted territory of intergalactic space. This engineering masterpiece has opened our eyes to the mind-blowing wonders that exist in our cosmos. In a recent development, Neil deGrasse Tyson has confirmed that Voyager has detected 500 unknown objects gliding peacefully in space. This news came as a shock to the scientific community, rattling scientists as everyone began poring over the data obtained by Voyager 1. Something strange was brewing on the horizon, and it was difficult to solve this bubbling puzzle that had dumbfounded even the best of scientists. Ever since Neil deGrasse Tyson confirmed this discovery, different interpretations have been flying in the air in an attempt to sketch a vivid picture that explains this mystery. If it had been another spacecraft that transmitted the type of bewildering data recently transmitted from space, scientists might have doubted the validity of the data. However, if it's Voyager 1 we are talking about, the space probe that has been cruising through the steamy parts of space for almost 50 years now and has exceeded our expectations, like a patient who beat cancer, Voyager 1 has exceeded scientists' projected lifespan of 3 years to spend over 45 years in space, uncovering historic discoveries. Simultaneously, the most intriguing part about this iconic tale is that Voyager is writing this success story from a very far distance from Earth. The last time scientists checked, they saw that the space probe was 145 billion miles away from our planet, speeding away in space with no sign that it would reduce its pace anytime soon. Researchers say that the space probe has been traveling at a rate 3 to 6 times the distance between the Earth and the Sun per year. This is one pill that scientists have found a bit hard to swallow because naturally, one would have expected the space probe's speed to have declined greatly given the longevity of its journey in space. On a close look, it seems Voyager 1 is destined to be the exception when it comes to this narrative, and it has shown evidence of this once more with its latest findings. It was just like every other day for scientists when Voyager 1 slammed exciting news on their faces, news that would stick in their memories for ages. Voyager 1 had stumbled on some mysterious objects passing by in space. This discovery was unplanned, which explained the initial confusion of astronomers when they glanced over data showing that about 500 unknown objects had appeared from nowhere. One minute we didn't know about the existence of these objects, and in the next moment, we had scientists cracking their brains in search of an answer to this puzzle that nature had landed on their laps. Scientists were in a fix, and the blame could be traced to only one guilty party, Voyager 1. Ironically, scientists also knew that the solution to unraveling this mystery rested on the heavy shoulders of the space probe. Initially, when news of this discovery broke out, some scientists considered the possibility that it could have been a mistake. They thought that the age of Voyager might first be catching up with it, and hence it may be transmitting wrong data back to us. If we decide to walk on this unfolding path, it seems like a plausible explanation, given the fact that Voyager 1 was launched as far back as 1977, almost 5 decades of active service on behalf of humanity. One can only expect that the spacecraft's computers would have grown weary and started to malfunction, shrinking in their responsibilities and sending back poor quality information to the ground team. As alluring as this narrative sounds, scientists have advised that we shouldn't tread there because it would be a slap on the selfless spirit of Voyager. Despite the harshness and unpredictable environment of space, Voyager 1 has consistently churned out eye-opening data about our cosmos. Contrary to the hurried assumptions of skeptics, the space probe has maintained its long life thanks to its dual redundant computer systems. Like its twin Voyager 2, Voyager 1 came equipped with two sets of command subsystems, Flight Data Systems, FDS, and Altitude and Articulation Control Systems, ACS. This has been the secret power behind the spacecraft's unbroken fighting spirit when it comes to charting through space and uncovering discoveries. The redundancy paved the way for seamless transitions between systems and the ability to activate dormant computer components, thereby preserving their lifespan. When designing Voyager, the engineers back on Earth came up with a plan to help the space probe maximize efficiency. This required that the probe's instruments rely on hardwired logic. They were taking no chances when it came to this area, as they were handicapped due to time constraints and limitations in power budgets. The electrical engineers decided the instruments would have to be developed using simplified systems power management that depended on hardwired logic. Thus, Voyager's computer systems comprised 6 onboard computers organized as a distributed system with 3 dual redundant pairs. Having overcome this hurdle, scientists had to face the next tall brick wall in their way, which was maintaining the systems. This intimidating height was surmounted by coming up with an ongoing power management plan. Here's where it gets a bit tricky. Power management entailed sustaining the operational capabilities of Voyager's computer systems. If we are being honest, this is an arduous task to deal with, given the limited power resources available on board the space probe. It was a case of sending a hunter into the deep jungle to hunt for wild animals with only a set of knives. Nevertheless, scientists found a way around this problem by devising several measures to conserve and optimize power usage aboard Voyager. A good example of these power management measures is the selective powering down of non-essential systems. Engineers were forced into making this hard decision and hence employed a systemic approach to identify and deactivate components or subsystems that are not crucial for the spacecraft's primary mission objectives. We see evidence of this when we take a quick look at heaters associated with certain instruments that had to be switched off. These heaters were originally designed to maintain the instrument at specific temperatures so they could operate or perform at optimum. However, the story had to be rewritten because it greatly reduced power consumption on board Voyager. This reduction in the spacecraft's power usage comes with a ripple effect, an extension of Voyager's lifespan. It's a win-win situation for everybody. Moreover, we should bear in mind that this decision to power down non-essential systems is not taken lightly. It is a premeditated activity that requires careful evaluation of the trade-offs between power conservation and the scientific objectives of the spacecraft. Whenever such a decision was taken, all hands had to be on deck. Engineers and scientists had to sit together and evaluate the impact of deactivating specific systems on the quality and availability of scientific data. Emotions weren't at play here. It was strictly business based on the facts at hand. The team was driven by the desire to maximize power efficiency while maintaining the essential functionality of the spacecraft so it could continue to gather necessary information about our universe undisturbed. Engineers and scientists alike didn't want anything to hinder Voyager's path when it came to uncovering the deep secrets locked away in hidden realms of space. Secrets that the universe has been keeping away from us for centuries. However, selective power reduction isn't the only way that NASA engineers are keeping Voyager afloat and operating optimally in space. They had another ace up their sleeves which they had to place on the table for the benefit of the spacecraft: adaptive power management. Alongside adaptive power management, scientists and engineers had to come up with power management strategies that are adapted to the ever-changing conditions of the spacecraft's environment. For instance, as Voyager 1 travels farther away from the Sun, the available solar energy takes a nosedive. We would agree that this is a problem. However, the engineers came prepared as they compensated for this growing threat by ensuring that the spacecraft adjusted its power usage accordingly. This adaptive approach is a masterstroke on the part of NASA engineers and scientists because it ensures that the available power resources are efficiently allocated to support the probe's key operations and data transfer back to Earth. Interestingly, the good news doesn't end here. There have been ongoing technical advancements and upgrades in power management, which have made room for engineers to refine and optimize the power systems of the spacecraft over the years. A close look at these enhancements would reveal that they involve more efficient power distribution, improving battery charging methods, and advancements in power regulation and control. The implementation of well-thought-out and planned power management strategies has opened an exciting door for engineers. It has made it possible for engineers to extend the operational lifespan of the Voyager 1 craft alongside its twin Voyager 2. This is a big win for the scientific community and the world at large. The careful allocation and management of power resources have equipped Voyager 1 with the requisite strength needed to keep exploring the depths of space unhinged, without fear of failure. The spacecraft has experienced an intriguing scientific journey, one where its critical systems remain functional despite its old age. Hence, it can transmit valuable data and provide groundbreaking insights into our universe. Scientists have confirmed that the space probe has been very active over the past few months. For example, Voyager 1's recent findings are an indication of its superior functionality, which stands in stark contrast to skeptics who would have dismissed these findings as mistakes. Engineers and scientists have shown that Voyager is indeed producing accurate data thanks to its robust power management strategies. This implies that the previously mentioned theory of the spacecraft being too old to transmit accurate data is no longer valid. With this in mind, scientists have turned their focus towards the possibility that the 500 unknown objects detected by Voyager are something new and not an error. The spacecraft's latest discovery demands more than just skepticism. It demands a closer look. The scientific community has concluded that the 500 mysterious objects could be classified into two categories: natural space debris and artificial space debris. The natural space debris comprises asteroids, meteoroids, and comets. These objects are formed through cosmic processes and are constantly floating around space. On the other hand, artificial space debris is made up of human-made objects such as spent rocket stages, defunct satellites, and other remnants from space missions. Considering that Voyager 1 is exploring uncharted territories far from Earth, it is highly likely that the spacecraft has stumbled upon new types of natural or artificial space debris previously undiscovered. This opens a whole new realm of possibilities that are awaiting exploration. In the long run, a thorough analysis of these findings will enhance our understanding of the space environment and the various elements floating in the far reaches of space. To this end, scientists are calling for the establishment of a new space observation program aimed at studying and cataloging these newfound objects. This is important because it will allow researchers to monitor and track the movement of these objects. Additionally, the program will help in understanding their origins and how they interact with other cosmic elements. The ultimate goal of this program is to prevent potential hazards posed by these objects to future space missions, as some objects might pose a threat if they come into contact with spacecraft, potentially causing damage or collisions. In summary, Voyager 1's discovery of 500 known objects in space has shaken the scientific community. However, the spacecraft's longevity and data reliability have been validated, leading scientists to explore new possibilities regarding the nature of these objects. With ongoing research and the establishment of a new observation program, the scientific community aims to better understand these findings and their implications for space exploration. The discovery of 500 unknown objects by Voyager 1 introduces a new chapter in our understanding of interstellar space. This revelation has ignited intense curiosity and a flurry of research as scientists work to decipher what these objects are and what they might signify about the broader cosmos. Voyager 1's recent findings have particularly heightened interest in the field of space archaeology. This emerging field seeks to explore and analyze the remnants of past space missions and artifacts that have been left in orbit or drifted through space. By studying new objects detected by Voyager, researchers hope to gain insights into the history of space exploration and how previous missions may have inadvertently contributed to the current space debris population. This historical perspective can provide valuable context for understanding the long-term impact of human activities in space. Moreover, this discovery highlights the need for improved space traffic management systems. As the number of objects in space increases, so does the potential for collisions, which could endanger satellites, spacecraft, and even future interstellar missions. Current space traffic management systems are primarily designed to handle objects in Earth's orbit, but as Voyager 1's discovery suggests, similar systems are needed for the vast expanse of interstellar space. Developing a robust tracking and collision avoidance system will be crucial for ensuring the safety and sustainability of space operations in the coming decades. Another fascinating aspect of Voyager 1's findings is their potential to shed light on the dynamics of interstellar matter. The objects detected could include previously unknown forms of matter or particles that have not been observed in the solar system. This opens up new avenues for research into the composition and behavior of matter beyond our familiar solar neighborhood. Scientists may discover new types of interstellar dust, novel chemical compounds, or even entirely new classes of celestial bodies. The discovery also underscores the importance of continuing to invest in and support long-term space missions. Voyager 1's success in detecting these mysterious objects demonstrates the value of persistent long-duration missions that can explore regions of space that are inaccessible to other spacecraft. As technology advances, future missions could be designed to follow up on these findings with more detailed observations and analyses. Such missions could deploy advanced sensors, imaging systems, and analytical tools to better characterize the newfound objects and their properties. Public interest in space exploration may also receive a boost from Voyager 1's latest findings. Discoveries like these capture the imagination of people around the world and inspire the next generation of scientists, engineers, and space enthusiasts. The idea that Voyager 1, a spacecraft launched nearly 50 years ago, is still making groundbreaking discoveries is a testament to human ingenuity and the enduring spirit of exploration. It serves as a reminder of the vastness of space and the endless opportunities for discovery that await us. Educational initiatives and outreach programs could capitalize on this renewed interest to engage students and the general public in discussions about space science and exploration. By presenting the discoveries made by Voyager 1 in a compelling and accessible manner, educators can foster a deeper appreciation for the complexities of space and the importance of scientific inquiry. Interactive exhibits, public lectures, and media coverage can help translate the technical details of Voyager's findings into concepts that resonate with a broader audience. In addition to its scientific implications, the discovery of 500 unknown objects by Voyager may first have practical applications in fields such as material science and engineering. Studying these objects could reveal new materials or physical phenomena that could be harnessed for technological advancements. For instance, if some of the objects are found to have unique structural properties, they could inspire new materials with enhanced strength, flexibility, or other desirable traits. Similarly, understanding the behavior of these objects in the interstellar environment could lead to innovations in spacecraft design and construction. As research continues, collaboration among international space agencies, research institutions, and private space companies will be essential. The global nature of space exploration means that discoveries and insights gained from Voyager 1's findings can benefit all of humanity. Sharing data, resources, and expertise across borders will enable a more comprehensive understanding of the objects detected and their implications for science and technology. In conclusion, Voyager 1's detection of 500 unknown objects in space represents a significant milestone in our exploration of the cosmos. It challenges our current understanding, prompts new lines of inquiry, and underscores the importance of continued investment in space exploration. By embracing the opportunities presented by these findings and working collaboratively, the scientific community can unlock new secrets of the universe and pave the way for future discoveries that will expand our knowledge of the great expanse beyond Earth.